Hey, welcome to another video in our series on deploying our web application to the cloud. This content will show you how to use AWS's application load balancer coupled with an auto scaling group to create a production environment that dynamically scales to the demand placed on those services. And it doesn't really matter if you're deploying a PHP application like we are, or a Node application, or a Python-based application. This content is generic. If you like content like this, be sure to hit that like button and subscribe. As always, it's useful to take a look at the road we've traveled. There's been a lot of videos in this series. I just want to give you a heads up of what's out there. We won't be covering kind of that old content. We started this video series with manually deploying an application. It was a monolithic application. Everything was deployed to a single EC2 instance, but we went through all the details of how would you provision Ubuntu, how do you provision the application and set everything. Then we did a couple of videos on DevOps where we automated some of that deployment, and we discussed a CI/CD pipeline. Then we started a series of videos where we talked about scaling. We slowly migrated our monolithic application to an application that has 4 tiers, which is where we are today. So there's a couple of videos on database scaling, on cache scaling, workers, and now we're in this web scaling. There's already 3 videos on the web scaling. In the past 3 videos for web scaling, we've covered vertically scaling, we covered horizontally scaling, and we also covered just kind of fine-tuning an individual instance. So we're, optimizing how PHP and Nginx behave. When we talk about scaling, it's important to understand, what we're trying to achieve. If you look at some kind of request response monitoring, from some examples out here, this top is from OpenStreetMap, and you can see they're hitting about 400 to 500 requests per second. If you look at a site like Wikipedia, they're into 150,000 requests per second. So your scaling solution really depends upon kind of what your load is and what you're trying to achieve. And your scaling option depends upon, what you're trying to achieve. If you have kind of a small website, maybe you don't have to worry about scaling at all. You can just deploy it to kind of a T2 micro and, it's not really getting used that much. But as your website grows, then possibly you want to vertically scale. Eventually, though, you reach a point where vertical scaling isn't really an option anymore, and you're going to have to go into horizontal scaling. And as I scale horizontally, there's architectural decisions that we have to make. We want to have our session data, not just stuck on one of those EC2 instances, but I should be able to hit any of those instances, and my session data should follow me. So architecturally, there's some choices that we've already made, and we've done that. Again, our application happens to be a Laravel application, but the content of this video, when we talk about the application load balancer and the auto scaling groups, it doesn't really matter what you're deploying. So at a high level, this is what we have in our Laravel application. We have, Nginx as a web server. We're using PHP FPM. We have a Redis queue. We have MySQL or an RDS instance in Amazon acting like our database. We initially started off with a single tier, a monolithic tier, where all of those different systems were deployed to one EC2 instance. So we very quickly carved off each of those kind of systems and put them on their own tier. And this is where we have landed today. And so what we're considering now is how do we scale this web tier? So this is where we first started. This is a no scaling. We have a single EC2 instance that has a public IP address. We set up our routes, our DNS routing, so that a user would request our website and that response would be handled by that single EC2 instance. Then we did talk about vertically scaling this, where our EC2 instance was still a single instance, but it was a bigger instance. It had more CPU, more RAM, and we showed those results. And in the previous video, we talked about kind of manually scaling this. So what if you didn't have access to some of the Amazon services like application load balancer or the auto scaling group? How would you do this manually yourself? With that scenario, we talked about having an EC2 instance act as a load balancer. We used Nginx for our load balancer. And that load balancer balanced the load between some EC2 instances, which is where our web application was deployed, and it balanced that load independently. And we talked about scaling this up. And I showed you how to manually scale this up to 5. We talked about the performance gains and all of that. Some of the things that we ran into last time is every single time I scaled this up, I added a new EC2 instance. This was a manual process. I had to create that instance myself. I created from an AMI, an image. Once that image was created, I understood what its IP address that was assigned to it, and then I added that manually to the load balancer. That was all very manual. It functions, it worked, but that's not really kind of where I want to be. So today, let's start taking advantage of some of the services that are offered by AWS. Here's where we want to kind of land at the end of this video is instead of our manual load balancer that was Nginx that we manually configured, we're going to use an ALB, an application load balancer, which is a service that's provided by Amazon. And we can configure this ALB to a certain target group. And in that target group, there can be any number of EC2 instances. And so it'll balance the load between all of those EC2 instances automatically for us. If in this target group there was only one server, all the load would go to that one server. But as soon as you added another EC2 instance, this ALB would automatically balance the load between those two. And as you scale this up further to 5 to 10 to 20, the ALB will automatically load balance between all those servers. On top of the ALB, we're also going to configure an application auto-scaling group. And within this auto-scaling group, we can set the kind of desired number of instances. You can set a min and a max. You can also configure where in your network you want this auto-scaling group to deploy these EC2 instances, so you can set the network up. You can define auto-scaling rules. So for, as an example, average CPU usage, if it gets above, say, 80%, you would like another EC2 instance to be spun up. So you can set up all these kind of auto-scaling rules that depend upon the CloudWatch, which is why you can see this is linked to CloudWatch here. And the auto-scaling group is configured to work with a certain load balancer. So as the load balancer is doing health checks, maybe the load balancer kills off an instance because it's been unhealthy. Well, this auto-scaling group will see that you're down an instance and you desired to have 3 all the time, but now you only have 2, and it'll automatically spin up another instance. And you can define what the autoscaler is spinning up using a launch template. And this launch template can have multiple versions, version 1, version 2, version 3. As you kind of, maybe improve your production environment, you can switch those versions and incrementally choose what you're scaling up. But essentially, this launch template for us today is going to point to an AMI instance. We can also determine the instance type, say a T2 micro. We can add security groups and the key pair that we can use to kind of connect to this. All right, so that's the background of where we're heading today. Let's get at it. All right, so as a way of kind of introduction, this is where we're starting at right here. And I just want to go through all these in the AWS console so that you can see kind of where we're at here. So I want to pull this out of the way. And now we're looking at kind of the AWS console. I'm looking at the EC2 panel right now, so you can see my instances that are running. I have this Laravel demo test, which I spun up from this AMI. And I didn't change anything with this AMI. This AMI is an image that I took a snapshot of a couple of videos ago. But inside this AMI is our application. So it's got a certain version of the Laravel code. It's got Nginx configured the way we want it. It has PHP FPM configured the way we want it. So after I spun that up, I ended up with this demo-test instance here. And you can see this has a public IP address, and it has a private one of 10.1.2.13. Let me bounce on over to our RDS instance. This is our database, and this is a MySQL RDS instance, and this is already configured up for us. So we're not going to change anything here with this instance. I just wanted to show that it's running. And then another thing I'll show you is the caching. We have an Elasticache instance, and you can see here we have this Redis Elasticache instance. And then finally, if we go to Route 53, you can see I have a single hosted zone, and inside that hosted zone I have this domain called Nextler, and here is our subdomain laraveldemo.nextler.com, and I've got that configured so that it's pointing to our EC2 instance. And so if I go back to the EC2 instance, that value is here. That's the same values we just saw on Route 53. So with that all said, if I go and hit this domain, here's our Laravel application. If I refresh it, you'll see new data being loaded here. It's kind of dynamically choosing some random coordinates in the world. And then based upon those random coordinates, it's grabbing the 10 nearest locations to that random point. And again, this is just all fake data. So these cities don't really exist at these locations. It's just data that I put in place so that I can have an example here. Over on the right-hand side, you can see the host name is 10-1-2-13, which is the IP address of our single EC2 instance. So that's where we're at right now. One of the first things we're going to do here is we're going to create an Amazon AMI. An AMI is an Amazon machine image. And I've already done that, so I'm not going to do it again. It takes a little bit of time. But if you click on any EC2 instance under Actions, you can go down to Image and Templates, and then you can click on Create Image and follow the instructions there, and you'll be able to create the AMI. And you want to create it obviously from whatever you have that's kind of functioning. I have this. This is functioning. It handles all the HTTPS requests. Inside of it has Let's Encrypt, so it's got a SSL cert installed in it, and everything's working perfectly fine for this image. So you can see this image over here in my AMIs list, and that's the image that we're going to configure our launch template to use when it wants to launch a new instance of EC2. It's going to use this AMI to create a new EC2 instance. All right, so the next thing that we're going to do is we're going to actually create the application load balancer itself. If you get to the EC2 panel, and the easiest way to do that is to type EC2 up in here and you can click on it. But once you're in the EC2 panel, you can see on the left-hand side, down at the very bottom, there's an option for load balancers. So what we're going to select is we're going to click load balancers. I currently don't have any load balancers configured, and we're going to create a new load balancer. You can either click this button or the button in the upper right, and then we're going to be brought to this page where we get kind of 4 choices. The bottom choice here is kind of a deprecated previous generation. It's not recommended that you use this, but they call that the classic load balancer. And the other 3 options here are either application load balancer, network load balancer, or gateway load balancer. And you can kind of see some diagrams of kind of how they're used. And for today's video, we're going to actually use the application load balancer. In future videos, I might circle back and cover the network load balancer, but today we're going to select this application load balancer. So we're going to click Create. And you can expand this little section here and kind of learn about how the application load balancer is going to work. But this is now going to be the front end of our application. We're going to configure Route 53 to direct all requests over to this application load balancer. So we'll go through the kind of configuring this. We're going to set up a name, and we're going to continue to use our naming convention where we prefix everything with Laravel-demo-, and this is going to be our ALB. And for our scheme, we're going to select internet facing. This internal would mean that it doesn't have a public IP address, and Route 53 will not be able to route requests to it. The next thing we're going to do is we're just going to leave this as IPv4. We don't need the dual stack in our example. Under our VPC, I'm going to select the VPC that we've been using, which is Laravel_demo_VPC. And then here I have to select at least 2 availability zones, and I only have 2, so I'm going to select them both. And for each of these availability zones, I'm going to configure the public subnet for both of those, so it has access to the internet. All right, the next thing that we're going to select is our security groups. I'm going to get rid of the default. And then what I'm going to do is I'm going to select a security group that I know that allows HTTP, HTTPS, and SSL traffic. So that's the security group that kind of allows that inbound traffic. And I'm going to select that security group. Here's where the application load balancer is kind of, we're configuring it how it's doing its work. We're going to listen for the HTTPS protocol. It's going to automatically select the port 443 for us. I don't really have a target group configured. So what we're going to do is we're going to create a new target group. It opens up a new tab for us. And then in this new tab, we're going to start to configure our target groups. Once we have this target group configured, we're going to go back to our application load balancer and use that. The target type is we're going to use instances here, and we're going to leave it the way that is. For our target group name, we're going to use our naming convention. And I don't think it'll make a difference later on, but I'm just going to differentiate this one by saying ALB-target group. And for the port, we're going to use that same port. So it's HTTPS. IPv4, the VPC is Laravel demo PC, HTTP1 is fine. Health checks, we are going to go to HTTPS because that's our protocol that we're using. And we're just going to use the slash there. Everything else is the same. Everything else looks good. So we're going to click next. And now what it's doing is asking us if there's any existing EC2 instances that we want to register to be a part of this target group. And we do. We have this Laravel-demo-test. And we're going to check that, and we're going to say include it as part of our target group. So inside our target group, we'll already have one instance running. And then we're going to create our target group. Once this target group is created, it'll go through some health checks. Right now, it hasn't had a chance to do the health checks yet, but we don't need that for now. We're going to close out this tab, and we're going to come back to our application load balancer configuration here. And I can refresh this list, and I should be able to now select that target group. You can add additional listeners if you want. They can be configured to route traffic to different target groups. We're not going to do that in this case. We just have a single HTTPS listener. In this next section, we're going to set up the SSL or TLS certificate. And what we're going to do is we're going to allow the Amazon Certificate Manager to create that certificate for us. So we're going to select this from ACM option. I don't really have any certificates at this point. I'm going to request a new certificate. This will open up a new tab for us. And you can see I don't have any certificates created yet. I'm going to request a new one. It's going to be a public certificate. And then I got to enter the fully qualified domain name. And this is going to be nextler.com. I'm also going to add another name to this. I'm going to add a wildcard certificate to cover our Laravel demo subdomain. So after I got the domains entered, the validation method is we're going to use this DNS validation. We control DNS through Route 53, so this is going to be easy. We're just going to add kind of a CNAME eventually to it. And in fact, it automatically kind of helps us out with that. The key algorithm we're going to keep the same, and we're going to request this certificate. Okay, so after it's created the certificate request, you can see it's all pending validation. And remember, the validation method is DNS validation. So what we're going to do is we're going to create a CNAME record that's part of our domain name system. And the name will be this, and the value will be that. But we don't have to really do this manually. It has an automatic thing here where I can create these records in Route 53. So I'm going to click this button, and now it comes up with this wizard. Yes, I want both these. I'm going to create both the records. It still says pending validation. As you know, DNS records, they take a little bit of time to kind of propagate. But if I go over to Route 53, let's see the changes it made over there. And I'm going to open this up into a new tab so we can keep this one open. I got that one hosted zone. Here's Nextler, and here is this new record. So it has a CNAME, and it has this name, and then here's the value there. And once that propagates, then this will become a kind of a valid entry over here. All right, so now if I go back to this create application, I have this select a certificate. If I refresh, I'm hoping it shows up. There it is. So now there's Nextler. In fact, it didn't show up right away because I think it was pending validation, but now if I refresh here, these are all successful. So it's been issued, and the validation, it's been successfully validated. So I don't need this tab anymore. I don't need this one either. But just note that it didn't show up in this drop down until it was validated. So you got to wait for that. As we carry on down through the configuration for this application load balancer, we're not going to do any load balancer tags. You can add key value pairs to tag this. We're not going to integrate with any other services like the application firewall, the WAF, or the global accelerator. And down here at the very bottom, it starts to summarize everything for us. So we're going to go ahead and create this load balancer. And now that it's been created, it has a DNS entry right here. And so that's the entry point now for our Route 53 records. So we're going to copy this. I'm not sure if I have to or not, but we're going to go back over to Route 53. Right now, if I refresh this, our website's still working. It still has the old DNS entries in there. What I'm going to do now is under our hosted zone, I'm going to select Nextler, and I'm going to do a couple of things. First of all, I'm going to edit this Laravel demo.nextler.com, edit that record, and I'm going to put the DNS name for our ALB. So that's our ALB DNS record. Save that. And then I'm also going to enter an A record here for our just top level domain, nextler.com. And then when you get in here for the A record, you can select this alias, and it'll take you through kind of a drop-down wizards here. We're going to select an application load balancer because that's what we have. For the region, I'm in Virginia, so I'm going to select my region. And then here's my network load balancer, or my ALB, I guess. And we're just going to keep the routing the same. So you have some routing options. You can weight it. You can, based upon kind of where they are in the world, you can route them to a certain servers and everything. We're just going to keep this as the simple routing. And I'm going to create that record. So these DNS records will take a bit of time to propagate, but once they do, then this should still function. It's functioning right now, but it could be functioning because the old DNS records just simply are still in place. But now if I go back to my EC2 instance and I look at my load balancer, which is here, and I select it, if I open up this target group, I can see that there's one instance in there, and that instance has that name. So everything is set up so far for our ALB. The ALB has a target group. That target group has one instance in it. There's no auto scaling yet, and we're going to get to that in the next section. Okay, so now let's set up the auto scaling groups. I'm in my EC2 panel here. So on the left-hand side at the very bottom, there's auto scaling group at the very bottom. We're going to start there, and we're going to select that. And it brings us to this screen because we don't have an auto scaling group yet. So I'm going to create an auto scaling group. And again, I'm going to name this thing the same way I've been naming everything so far. The next thing it asks for is a launch template. I don't really have a launch template created yet, so we're going to use this button at the bottom, and we're going to create a launch template, which will open up a new tab for us. Every time you create a launch template, or you come and you edit it or modify it, you're allowed to put kind of a version description here. You don't need to do this, but it's helpful sometimes to kind of differentiate between version 1, version 2. So if you tell it what the differences are. So I'm just going to put initial version here, and that'll let me know that this was the initial version. Once again, you get the option to add kind of key value pairs for tags. You can also set the source template. Right now, I don't have any sources that I'm going to use, but later on, we have different versions. I could create a version, say 5, based off of version 1 if I wanted. So that's what that's for. So we're not going to select a source template though. For the AMIs, this is where we're telling it, what are we going to build these EC2 instances using? And we're going to select my AMI, and I only have one. I have this Laravel demo image, and so we're going to select that. The instance type here, now I get to select the kind of instance. I'm going to put this on a T2 micro, so we're just keeping it in our free tier. When it launches, this is the key value pair that I've been using for all of this project, so we'll just continue to use that. All right, the next section we're going to fill out is the network settings. I'm not going to select a subnet at this point. Later on, we'll be able to actually, when we use this launch template, we'll be able to select a subnet where we're going to deploy this to. I do want to add a couple of security groups, and it's the same ones I added before. So we're going to select existing security group. From here, I'm going to have my options, and I want to use this web app security group is one of them. And this one allows HTTP, HTTPS, and SSL traffic into that EC2 instance. And the other one that I want to add to this is this EC2 RDS2 instance. This was created when I registered an EC2 instance with the RDS database. If I don't add this to the EC2 instance will not be able to communicate with the RDS database. So you should have one of these hanging around if you've already registered manually an EC2 instance. If you don't, you may have to manually create this. We can take a look at this a little bit later, but this allows port 3306 as outbound traffic from that EC2 instance to our RDS. And so now I have both of these security groups added to the EC2 instance. I don't think there's anything here that I need in this. I'm just going to remove this. EBS volume, we'll just keep all the same. All the advanced details, we'll keep the same. And I think that is everything that I need to do to create this launch template. So I'm going to go ahead and create the launch template. And now it's been created. So I should be able to just go back and look at the launch templates. Now I have one here. And if I go back over to my auto scaling group and I refresh, I should be able to now select that launch template. So now this auto scaling group can use that launch template whenever it needs to. And here is where you can get the versions. So right now I'm doing the default version, which is version 1. I'm going to go ahead and just select this as the latest version. So if I ever have different versions of that launch template, so I make tweaks to it, I just want this auto scaling group to always use the latest one. So I'm going to go ahead and select that. And I'm going to click next. And so now we're at step 2 of this wizard. So there's 7 steps. So we're going to go through the second step here. All right, so now here's where I can configure that network. So using this auto scaling group is going to use that launch template, and I can specify where it's going to create new instances. And what I'm going to do is I'm going to use our demo VPC, and I'm going to select the private subnet number 1. And so that's where I want it to build instances. Now you may ask, Well, don't we have an instance already kind of created? It's in the public subnet, right? So we created one that has a public subnet. And I created that originally because it needed a public IP address for us to access it. These new instances, when it creates these up on this auto scaling group, they do not need a public IP address. In fact, I don't want them to have a public IP address. I want all requests to come through my application load balancer. And so by putting these in the private subnet, I'm kind of isolating them. And the only way to get to them is through our ALB. So that's what we're going to select here is we're going to select that private subnet. We're going to select next. And so now it's asking about the load balancer options. We have a load balancer, and I want to attach this kind of auto scaling group to that load balancer. So I get two choices here. This is the classic load balancer. So if you have an old balancer that's using the classic load balancers, you can select that, but we have one that's over here. And in this drop down, here is my ALB. So I'm going to select that as my load balancer. For the VPC lattice integrations, I'm just going to keep this as this default, which is no VPC lattice service. Okay, so next thing is about health checks. What these health checks are for, again, if you remember in our launch template, we had a health check URL. So we just put the / endpoint there. And what these health checks is going to do now is going to enable the application load balancer to kind of query or pull all these EC2 instances and see if they respond. If they don't respond, and what it means to be a successful response is it could be, 5 successful responses out of 10 or whatever it is. You can define those numbers in your health checks. But if it's determined that the instance is unhealthy, then the auto scaling group will kill off that instance and create another one for you. And so in production, we really should turn this on. So one of the challenges with health checks that I found was if your health check is at a subdomain, so we got laraveldemo.nextler.com/, that's really my health check URL. It's not going to go there. It's going to nextler.com/. And I don't have anything handling that endpoint. So it's not really a fair health check here. So I'm going to uncheck this for our particular prototype. I don't really have an endpoint that it's going to be able to health check. I don't want it killing off my EC2 instances. So I'm unchecking this. But again, for production, you should absolutely check that. Now we're in this additional settings area. So if you look under monitoring, if you click info, you can kind of read over here. And so for the auto scaling group, you're able to kind of set parameters where, if the CPU usage gets above a certain threshold, it will automatically create another EC2 instance for you. So I think you want to go ahead and check this box because it helps you, as it says over here, you get increased visibility into the history of your auto scaling group. So if your auto scaling group is going from 3 to 5 and you're not understanding why it went from 3 to 5 or 3 to 4, or could go the other way from 5 down to 1, this is going to provide you some increased visibility. I think there's no harm in this. There may be a little additional CloudWatch costs, but I would definitely do this. All right, and then the final setting here for additional settings is the default instance warmup. And if you click on info, you can see it over here. But essentially this warmup, if you enable this warmup, you're going to be allowed to enter a certain number of seconds. So let's say that your EC2 instance takes about 60 seconds for Nginx service and PHP service and everything to kind of settle in and be ready to go. You can enter a warm-up instance here where the EC2 instance is being created by the auto scaling group, but it won't be put in service until after this threshold has been reached. So once it's been reached, then it'll start directing traffic to it. So we're going to go ahead and select next on this one. And so now here we can start to set our auto scaling size. I'm going to bump this from 1 to 2 because I know I already have one instance running and I want this as soon as we turn this on or save this, I want it to start to look and see, why I need one more instance. So I'm going to have it automatically create another instance. We'll set that to 2, see what it does. As far as the scaling limits, min, I'm going to put to 1, and then for max, I'm just going to set it to 10. So you can't have any more than 10. For now, we're not going to set any auto scaling policies. I just want to see what this does manually. In a little bit, we'll come back and reconfigure kind of the auto scaling policies, but you can configure them as you set them up here. So you can name it, you can select what different types you want. So CPU utilization, the target is 50. You can enter that warm-up instance also. For now, I'm not going to put any policies in place. So the next section, you get to select the kind of the maintenance policy. So as new instances are created, what's the policy? Do you terminate old ones first, or do you create new ones first? For now, I'm just going to leave this as no policy, but you can read the different policies here that they have. And then this final thing, the instance scale and protection, I'm not going to enable this. I'm going to select next. As far as notifications go, I'm not going to enable any notifications, but here's where you could enable like a SNS or an email notification, so that when scaling happened, you would get notified. But I'm going to select next. Optional tags, I'm not going to add any new tags here. Click next, and now we can review what we have. I'm going to go ahead and create this auto scaling group. So after I create the auto scaling group, you can see the desired capacity I set it to 2, 1 to 10 is the max. Here it says it's updating its capacity. So what that means is kind of in a transient state right now. It's evaluating these numbers here and seeing what it has in the target group, seeing if it needs to add another EC2 instance, or does it have to kind of decrease any. At this point, I don't think it'll decrease any, but I definitely set this to 2. I know I only have 1, so we'll see what it does here. In the details, you can see kind of all the details that we just kind of configured. Up here, activity-wise, there's a history. You can see all the history. Automatic scaling. This is where we can add policies, and we'll add policies in a little bit. Instance management. Right now, there are 2 instances, and maybe it already created one while I was talking. It says that they're both in service. I'm going to go look at these in just a second. Monitoring is enabled, so we can kind of see everything. Okay, so I want to just go back over to my EC2 panel and see the instances right now, because it says that it has created 2. All right, so what I see here is these are the 2 new instances. They're both kind of initializing. It's created these instances. It did not, when it did its count, it did not consider that I already had this test one in there. So that's interesting. So this one, it doesn't really include in the auto scaling group. Once these 2 have spun up, I'm going to go ahead and delete this one. This was our original one that we had in there. We don't really need it anymore anyways, because now we have this auto scaling group. But let's give this a moment and let it do its thing. So it's already past 1. Okay, so a little time has passed. These 2 instances, which are part of the auto scaling group, have kind of spun up. They're running. They've already passed their status checks. What I want to do is go to our application here, and I want to refresh this. As I refresh, take a look at the IP addresses that it's hitting over here. We should see, what we're expecting to see is, we should see a .13 address, which is from our original Laravel test. We should see a .173 IP address, because that's from the auto scaling group. That's the first one. And then here's the second one, .73. So if we keep refreshing, I see the 178, I see the 13, I see the 73. And so it is going between all 3 of those servers now, and it's balancing the load. It looks like kind of round robin style, just between all 3 of those servers. So I have this Laravel-demo-test. Again, this has a public IP address. You can see it right here. If I click it, I would be able to access the website through that public IP address. This is not the behavior that I want to have happen. So if I go down to our load balancers, and I select the load balancer, and I open up our target group, inside our target group, I have these 3 instances. So you can see these are the 2 that the auto scaling group just created, and this is the one that's just hanging around that I created manually. And so what I'm going to do is I'm going to check this, and then I'm going to click the deregister button. And what that's going to do is it's going to remove it from the target group, so that the ALB only thinks it has these 2 in there. And so you can see it's going through this process where it's going to give it an opportunity to drain off any current connections and everything like that, but eventually it should disappear from the target group. And then when I start to refresh over here, I shouldn't get that -13 instance anymore. And that's the proper way to remove an EC2 instance from the target group. And I'm just checking back. It still looks like it's draining. If I go to my EC2 instances and I look at the instances themselves, and maybe only the running ones here, you can still see demo test is running. These 2 are the auto scaling group. I wonder if I can put a name in there. Maybe that's one of the configurations I missed, as a kind of a name. But those are from the auto scaling group, and this one is currently being drained from our ALB. Once it's drained from the ALB and it's no longer being used for the ALB, it still is an EC2 instance. The next thing I can do is I can then terminate that instance because it's no longer being used. All right, so at this point we have an application load balancer configured. You can see that here. And we also have an auto scaling group that's associated with that application load balancer. All right, it's been about 5 minutes or so, and now it looks like that registered target, the old one, has been deregistered. It's no longer showing in my list. That's a good thing here. If I go back to the instances, you can see that it's still running right there. So if I just filter through all the running instances, you can see that these are the two that the auto scaling group has created because I asked it to create two. This is the one that I manually kind of registered with it originally. At this point, I no longer need this one. So what I'm going to do is I'm going to go ahead and just stop this instance. I could terminate the instance, but at some point I might want to roll back to just having the demo test with no application load balancer in front of it. So for now, I'm just going to stop it. It's no longer being used. And if you remember, as I refresh the website, that -13 IP address, which was the IP address for that -test EC2 instance, is no longer being cycled through. So I just have the two that are in the auto scaling group. All right, so now I refresh. I only have the running EC2 instance. The Laravel demo test is now gone. One of the things I want to do is I want to see how the auto scaling group kind of functions. And here's the auto scaling group down here. Let's play around with this a little bit. It has a desired capacity right now of 2. That's why we have 2 instances running, and it goes up to, say, 10. I'm going to edit this, and I'm going to say I just only want one of them running. And so I'm going to update this. And then if I look at the auto scaling group, it says there's 2 instances running, but the desired capacity is 1. Status is a dash. I'm not sure what that means. If I go back to my EC2 instances, though, let's see what's over there. Still has these 2 both running. If I look at my Elastic Load Balancer and this target group. All right, so now you can see in the target group that it's draining one of those instances. So I said I only want really one. That's my desired. And so it's going to keep this one around. It's draining off this one, just like it did with the manual one. And pretty soon this will no longer be available. If I go to my website and I refresh this, you can see the IP address is only the -73. So I'm only getting that -73 now. So that's kind of working as I expected. And just kind of summarize that workflow. If you edit this manually and you set the desired capacity to whatever number it will, if it's going to increase, it'll spin up those instances, it'll add them to that target group, and then once they're in service, those IP addresses will be available to the application load balancer, and it'll start to kind of balance the load between those new instances and whatever the existing instances were. If you're decreasing in the capacity, then it will remove instances, and the way it does that is it drains them off the target group first, so it allows a certain amount of time where no new connections are hitting that, and it allows all the old connections to kind of do whatever they're doing. So if there's like a long response, it'll fulfill that response, and then it'll be drained off eventually. And then those EC2 instances will eventually be terminated. So we look at the target group, it still says it's draining this. I expect that eventually it'll drain it, and then it will remove it from the EC2 instances. We'll just take a little pause and let that happen naturally, and then we'll come back in a little bit. Okay, so I'm going to just refresh this. I think it's still draining here. It finally drained off. So finally, after configuring it to, my desired capacity is 1, it drained off one of those EC2 instances, and you can see it's no longer part of kind of the target group. I want to go over to the EC2 instances panel and look at the running states. Actually, this is more informative here. So you can see this is terminated. So this was the EC2 instance that the scaling group created for us, and now it's terminated that instance. So it's going to automatically delete that for us. So we did an example of where we manually scaled this down by setting the desired capacity to 1. Let's go ahead and scale this up. Let's do kind of the example that we had in the past where we set this to 5. We want 5 as our desired capacity. and we're going to update this and see what happens. So desired capacity is 1. Now its status is updating capacity. You can see the desired capacity. As far as instance management, you can see now here that there's 1 that's in service, and then there's 1, 2, 3, 4 to get up to my desired capacity of 5 that are pending. If I look at my EC2 instances now, and I refresh this, you can see now there are 5 running instances. 1 has completed its checks, and the other 4 are initializing. So I look at the target groups and I select our desired target group. You can see that the target right now, there's only 1 target. So the process of scaling up is the opposite of scaling down, right? So it creates these new EC2 instances. It waits for them to get healthy. And then once they're healthy, it'll add them to the target group. And once they're added to the target group, then the load balancer can start to balance the load between the new instances. So we're just going to wait here for a little bit and let these start to appear. And actually, as I just refreshed it, now all 4 are there. So they're all healthy, ready to go. I don't know what the IP addresses are, but we should expect 5 different IP addresses. So if we go back over to our application and we start to refresh, we should see it bouncing between a number of different endpoints. So let's just refresh this a couple of times. You can see the different IP addresses are kind of coming in there. It doesn't quite look like it's a round robin because I see 73 coming in there more often than every 5 clicks. But let's go look at our EC2 instances again. Here's our target group, and I have these 5 instances. And again, from our auto scaling group, I look at instance management and I see the 5 that are there. And if I come back up here and I just refresh, I want to see the running instances. I see my 5 instances. If I take off this and I see all the different states, I can see my 5 running. I can see the 1 that got terminated because we kind of scaled it down manually. That's my Laravel demo test, which I manually stopped, and that was a load balancer that I manually stopped earlier. So we've just seen how, if we manually scale down or we manually scale up, how the auto scaling group kind of works. All right, so now I want to explore some of the configuration options that are available to us. So if we go to our auto scaling groups and I select the one that we've got configured, you can see the details here. I've set the desired capacity back down to 1. It's in the process of kind of updating that capacity, so draining those EC2 instances from connections, and then it'll remove and delete them all. So we'll let that happen in the background. So here's the launch template. I want to just click edit here and see if there's any changes that I can make that would make sense. So I don't see anything here that I want to do any change to. So I'm going to go back to the auto scaling group here. The networking, I'm not going to make any change here. I'm going to keep this in our private subnet. Theoretically, what you can do is you can select additional subnets. So we have this Laravel demo PC. I got private subnet number 1, but if I want to make this scaling group span multiple availability zones, I could put this also in private subnet number 2. Now I'm not doing that because I have RDS and there's some additional costs associated with data that's spanning multiple availability zones. So I'm just going to leave that off, but that's your options. You can make your application a little bit more resilient by spanning multiple availability zones using the auto scaling group. So it'll automatically scale them in different zones. I'm not going to turn that on, but that's how you would. The instance type, this is part of the launch template, the instance type requirement. I'm just sticking with this T2 micro. Here you could override kind of the launch template. So if the launch template said T2 micro, but what you really wanted was a T2 XL or something like that, you could override that. I'm leaving that the same for now. This is the load balancer that's configured for. I'm not going to change that. You could modify some of these health checks. The instance maintenance policy, this is where you can come in, you can select from these 4. So if you wanted to play around with setting a different policy, you can come in and change those. And then there's a section called advanced configurations. Let's go ahead and look at that. Here's where you can kind of configure which EC2 instances are terminated and things like that. So there's termination policies. Right now I'm selected default, but you can see some of the options here. You can say that I want the oldest instance to always be kind of terminated, Or you can say the one that's closest to the next hour, so that maybe you're saving some costs. So you're always kind of terminating the ones that are going to come up to the next hour and cost you more money. So you can select those. So I'm just going to leave it as default, but know that this is where you would kind of come in and set those termination policies. You can also suspend certain processes. So if you want to suspend launching or the health check, you can suspend them here. Now, if you suspend, for example, launch and terminate, you're kind of turning off auto scaling. So it's hard to kind of keep the auto scaling group really function if you turn those things off. But for example, health check, if you had a URL that just wasn't working anymore and you want to temporarily suspend the health check, you could do that from here. So here's where you can kind of set the maximum instance lifetime. And then once it reaches this instance lifetime, the auto scaling group will manage shutting that instance down. It'll go through that draining process and then terminating the EC2 instance. I'm just leaving that as unset. There is a cooldown period here, and what that is, if you look over here, after some scaling activity happens, then there's kind of a cooldown before another scaling activity can happen. Sometimes this is useful if, for example, imagine we set up a monitor for the CPU usage and it's going to scale up. I don't want it to monitor that CPU usage. I scale it up by 1, and then 5 seconds later it's still at a high CPU usage. The other EC2 instance, it hasn't even come online yet, and it's already trying to scale up. So there's this cooldown period before scaling activities can happen back to back. And then here's that default instance warm-up, which you can override. So I'm not going to change anything there, but just know that those advanced configurations are available for you. You can see the activity logs here. It's gone through terminating those extra instances because I asked it to scale back down to only 1. And here is where I want to start playing next, is the auto scaling. Obviously it's useful to be able to manually scale, and I can set the number of instances. But what's even more useful is if the auto scaling group can kind of trigger some scaling activity off of CPU usage or network usage. And that's what these dynamic scaling policies allow. So we're going to create a dynamic scaling policy. There's 3 different types. We're going to keep it as the target tracking scaling. I can set the policy name. We'll just go with that for now. And we're going to use the average CPU utilization. And what that means is if you look across all the EC2 instances, so let's say there's only 1 instance, if the average CPU usage is above this number, it'll scale up. If it's below this number, it will scale down. As you add more and more instances, what we're trying to get is it to kind of balance itself out and figure out where it needs to be. So I just want to set this for now. We're going to keep it as a target value of 50%. We're going to keep the instance warm up. We're not going to override this. It's at 60 seconds right now, so we're just going to keep it at 60. Here's where I can make this rule just scale out only, or it can be both scale in, scale out. So we're going to leave it as both scale in, scale out. So if my average CPU utilization goes below 50%, I can start removing instances. So we're going to leave it like that for now. And I'm going to go ahead and create this new dynamic policy. And so you can see the dynamic policy is here. All right, before we try to trigger this, I want to look at some of these other scaling options here. There's this predictive scaling option, and this is kind of more a longer time span. So think about the dynamic scaling. This is kind of instantaneously. What's the instantaneous or average CPU usage? This is looking over maybe a couple of days. What's this trending like? And then you can use that data to kind of predict what you're going to need, and you can have some kind of longer term predictive scaling policies here. And the other option that sometimes happens is, for example, at the end of the month, there's always certain activities that ramp up and you need to scale up at the end of every month. So here you can create a scheduled action, and so you can name this and put the desired capacity min max. So you can set this up so you can tell it when it recurs. Is it occurring monthly? You can use cron as the most generic type of thing, but maybe it's once every week. Every week on a Friday, we get a massive hit, and so you can scale up. So you can set these kind of scheduled actions. We're not going to set any scheduled actions. I'm not going to set any predictive actions, but I do have this dynamic scaling policy on the CPU set. Right now, if we look at our instance management, there's only 1 instance that's in service. If I go back to my target groups, I should see that 1 instance over here also. and you can see that there. If I go back to our instances, all of our instances that are running, I should see only one instance that's running. What I want to try to do is trigger that dynamic CPU instance. And what I'm going to do for that is I'm going to use our loader.io, and I'm going to go ahead and get to my account, and I have this demo test. It's going to hit our endpoint, and we are going to see if we can trigger that dynamic auto scaling feature. So we're going to run this, and this is ramping up the number of requests from 0 to I think 3,000 requests per second. At this point, the CPU usage on our single EC2 instance should be pretty high. If I can get maybe monitoring here, I don't think this is going to be granular enough to actually see it. But what I'm hoping for is that our auto scaling group will get triggered. So far, nothing there. And this test is complete. I'm going to kick off another test because I want to keep banging on this to maybe try to trigger that CPU usage. All right, so I think banging on this thing has produced an unhealthy EC2 instance in my targeted group. This health check is happening because it knows a URL and it's trying to hit that URL, and it couldn't hit it because I'm hitting it too hard from this external service, and so it couldn't get a response from the URL, and it marked it as unhealthy. So that kind of brings me back to when I originally configured this auto scaling group. If you remember, down here where it says health checks, if I look at and edit this, I'm not doing any load balancing based upon health checks. So I'm going to go and turn this on. Let's see what it does. So it'll start to detect now if the health checks are happening, and it'll try to kill those EC2 instances and spin them back up. Let's go ahead and update this. My target group here still probably says it's unhealthy. Let's see if I can reach it, that site. It's spinning. Still running. I think what we're dealing with here is that the ALB, it's kind of smart, and it knows that there aren't any healthy endpoints, and so it's not routing it to anywhere. It's just kind of holding it. Now it's routing again. Now it's hitting the 217 endpoint, which is not my instance endpoint. So the auto scaling must have created another running instance. You can see it here. Here's another running instance. It's initializing it. 217 is the endpoint of that instance, and that's what is being hit here now. So auto scaling has kind of kicked in. It's detected that there is an unhealthy one, and now it's kind of reacting to that. So if I go back to my auto scaling group and I go to the instance management, you can see that there's this one that's in service that's running. It's terminating this one, and there's another one that's kind of pending. So we go back to my EC2 instances. There's one that's running. This one is initializing. So here's two that is spinning up initializing. This one here says it's running, but it's eventually going to be switched to terminating maybe. All right, so I go back to my application. I hit it. I'm seeing two different endpoints, 217 and a 222 endpoint. The other endpoint, if we go to my target group, the other endpoint, and refresh this. Now I see two healthy ones, and there's one that's draining away. So it's going to drain that other one where it deemed it as unhealthy. It's going to drain that off of this target group, and then it'll terminate that instance automatically for us. So if I go back to my auto scaling group, I kind of wonder why it chose 2. Desired capacity is now 2. I didn't change that. I set it to 1, but at some point there must have been some activity maybe that changed it to 2. So here we go. So we can see at some point that there was an alarm that triggered the policy scaling CPU, and it changed the desired capacitor from 1 to 2. So that's the impact of kind of the auto scaling that we saw. So when we selected and we configured this auto scaling dynamic policy. It hit this policy threshold and it decided that it needed to go from 1 to 2. So as I completed the video, I was going back to kind of tear down everything that I built up. So I just minimized my AWS charges. But I wanted to record this because here you can kind of see some of those actions that the auto scaling group did. Originally, I think I just showed this one where it scaled up from 1 to 2 based upon kind of the CPU alarm changing that was in CloudWatch. But you can also see here, it's then scaled up from 2 to 4. But then at some later point, because I kind of wasn't really hitting that endpoint at all, it decided to scale it back down from 4 to 3, and then from 3 to 2, and then 2 to 1. So that auto scaling group's always watching kind of your EC2 or your ALB, and it's just reacting to what it sees on that CPU usage. And obviously there was other targets too that you could configure for the auto scaling. All right, so we've kind of completed what we wanted to do when we set out at this video. We've set up a application load balancer, and initially we've kind of seeded that target group with the one that we created manually, and then we created this application scaling group where we had a kind of a launch template and we could manually, for example, scale up or scale down. We also configured a kind of a target where it would automatically scale up and down based upon the target, and that would impact the target group here. We also saw how kind of the scaling worked under the hood a little bit. When auto scaling wanted to scale down, so it first removed it from the ALB, and then it allowed a certain draining time where kind of any existing request responses were just finished up. Once that draining time is completed, then it would terminate that EC2 instance. And on the opposite end, when we scaled up, we saw how it would create the EC2 instances, allow them kind of a warm-up period. Once that warm-up period was completed, then it would configure them with the ALB, and the ALB will automatically start load balance in between them. So now, there is some outstanding work that I didn't do during this video. But to keep this video kind of short and concise, we're going to push that off to other videos. So first of all, there's some load testing we can do. We did the load testing earlier on kind of an Nginx kind of load balancer, and it was the proxy between kind of the EC2 instances. I suspect that the ALB that Amazon is supplying is at least as good as that Nginx load balancer, maybe better. I'm probably not going to dig into kind of having a whole video on this loader IO testing for this. I might do that if there's interest. If there's interest, leave a comment below. Otherwise, I'll leave that to you. One of the big outstanding tasks is, if you have a code change right now, how do we get that inside the AMI? I didn't cover that in this one because I wanted to decouple these videos a little bit, but we have to circle back and talk about our CI/CD. How are we going to create that new image? And for that, normally we would leverage kind of some containerization technology. And I want to get into using containers in maybe the next couple of videos here. Another outstanding task is now we have this new infrastructure. We have this ALB, we have this auto scaling group, and we manually created those again. A while back, we created some CloudFormation JSON files to kind of build our EC2 instances and set up Route 53 for us. We could do the same thing here for this auto scaling group. And that's something, when I get more towards the end of this series, when I have all the pieces in place, that's something I'll circle back to, and I want to cover more of infrastructure as code. All right, so that's it for this video. If you have any questions or any comments, feel free to leave those below. And again, if you enjoy content like this, hit that like button and subscribe.